This facility operates 24 hours a day, producing the next generation of climate control systems for a global market.
Electronics,
all right, keep coming back straight. Watch your left side.
And refrigeration components.
Okay, hold it right there.
So
We're
how
clear.
does a collection of raw materials become a modern air conditioner? This is how AC units are made inside a high-speed factory. The process begins with raw materials. Large steel and aluminum sheets arrive at the factory and are inspected for thickness, surface quality, and dimensional accuracy. Copper tubing arrives in large coils, while compressors, motors, electronic boards, fans, plastic housings, and other components are prepared for assembly. The steel sheets first enter automated cutting and stamping machines. Power presses cut and shape the metal into panels, brackets, frames, and structural components for the indoor and outdoor units. The stamped parts then pass through bending machines that create precise angles and folds. These operations allow thousands of identical components to be produced quickly and consistently. Meanwhile, one of the most important parts of the air conditioner is being manufactured, the heat exchanger. Copper tubing is fed into specialized machines and bent into carefully controlled coil shapes. Thin aluminum fins are produced separately. These fins dramatically increase the surface area available for transferring heat. The copper tubes are then inserted through the aluminum fins. Specialized equipment expands the tubes so they grip the fins tightly, creating a compact heat exchanger coil. This coil will later absorb or release heat depending on its position in the air conditioning system. The factory also prepares the refrigeration tubing. Copper pipes are cut to precise lengths, bent into the required shapes, and prepared for connection. At another station, the compressor is inspected before installation. The compressor is the heart of the refrigeration system. It circulates and compresses the refrigerant, allowing the system to move heat from one location to another. Electric motors are prepared for the indoor and outdoor fans, while circuit boards, sensors, wiring, and connectors are assembled into the electronic control system. Now the major components begin coming together. The indoor unit assembly starts with its plastic housing and structural frame. The evaporator coil is installed first. The indoor fan and motor are positioned behind the coil, followed by filters, sensors, drainage components, wiring, and control electronics. The front panel is then installed, creating the familiar indoor air conditioner unit. At another assembly line, the outdoor unit begins taking shape. The steel cabinet and frame are prepared first.
The compressor mount goes right here.
The compressor is mounted on vibration isolating supports.
Securing the bracket now.
The outdoor heat exchanger is positioned inside the cabinet, followed by the fan and motor. Copper refrigerant lines connect the compressor, heat exchanger, and other parts of the refrigeration circuit. The tubing is carefully secured to prevent unwanted movement and vibration. Once the refrigeration circuit is complete, the system undergoes leak testing. The circuit is pressurized and monitored for pressure loss. Specialized equipment can detect extremely small leaks that may not be visible to the human eye. After passing the leak test, vacuum equipment removes air and moisture from the refrigeration system. The correct amount of refrigerant is then introduced using precision charging equipment. The charge must be carefully controlled because incorrect refrigerant levels can reduce cooling performance and efficiency. The completed unit now moves into electrical testing. Connections, grounding, insulation, sensors, and control systems are checked before the air conditioner is powered on. The compressor starts. The fans begin rotating. Electronic controls communicate with the different components while sensors monitor the system. Then comes one of the most important stages, performance testing. Finished air conditioners are placed inside controlled testing chambers. Engineers measure cooling performance, airflow, power consumption, temperature changes, refrigerant pressure, noise, and vibration. These tests confirm that the unit operates within its required specifications. Units that pass testing move to final inspection. Workers check the exterior panels, air outlets, filters, controls, connections, and overall finish. The approved units are then prepared for packaging. Protective materials are placed around the indoor and outdoor units to prevent scratches and impact damage during
All right,
transportation.
guide it slowly past the threshold.
Remote controls,
Watch the cables
manuals,
on the left side.
installation accessories,
Clear.
and
Initiating
other
door
components
sequence.
are packed with the appropriate units. Large cardboard cartons are formed around the products, sealed, and labeled. The packaged air conditioners are then arranged on pallets. Protective wrapping secures the cartons and keeps the load stable. The finished pallets move into the warehouse, where they wait for distribution. When an order arrives, forklifts transfer the required units to the loading area. Large trucks are loaded and the finished air conditioners begin their journey to homes, offices, shops, hotels, and commercial buildings. What started as sheets of steel and aluminum, copper tubing, electronic components, motors, fans, and a compressor has become a complete cooling system. The compressor drives the refrigeration cycle. The heat exchangers transfer heat. The fans move air. The electronics control the operation. And the refrigerant carries heat through the system. Every component must work together precisely. From raw metal to the final cooling test, modern AC production combines metal forming, electronics, refrigeration technology, automation, and strict quality control. The next time an air conditioner cools a room, remember the complex manufacturing journey behind it. From simple sheets of metal and coils of copper to a machine capable of moving heat out of an entire room, this is how modern air conditioners are made.